All right, guys. So we're going to talk today about more about the chain rule. We're just going to do some different problems. You guys picked up your notes. Okay, we're basically going to follow through with your notes. There's a new relevant app again, guys. It's in the Wednesday folder for today or for this week. I'm just telling you because some of you guys, if you have time, then you can work ahead. But I always give you 2 weekends to do it. Okay, so you have this coming weekend to do it, and then the next weekend to do it, and it will be due on October 12th. Your test, guys, is this coming Monday. Okay, so not today, of course, but we're going to work on chain rule today. We're going to work on implicit differentiation, and then, guys, Thursday's homework will kind of be on light homework. Okay, well, I think it will be light, and then and so it'll give you some time on Thursday. Just ask me questions. Okay, any questions that you guys have on derivatives. And then, guys, Friday we're going to do a start the new unit, and Monday will be the test of everything up to Thursday. Does that make sense? Okay. Yeah. Not this week. The test is Monday. Yes. Is that? Do you have an old calendar or something? Yeah, I've been changing. Yeah, I've been changing your calendar. So if you go to Schoology and just click on the calendar, your calendar, I don't know if you know, it changes like almost every week. Okay, so sorry about that. Yeah, don't look at the old calendar. All right, so your test is Monday of this week. All right. Oops, I don't know what that one's either. Okay, let's go ahead and do some problems together. Let's look at this problem right here, guys. All right, when you see this problem here, okay, and it wants you to take the derivative, you should be saying, yay! Why? Because look, there's a plus sign right here, okay? And so you thought you had to do one problem, but guess what? Oh boy, yay! You get to do 2, okay? And you just do 2 separately, like act like they're different problems. This is a problem, this is a problem, and then this is a problem, and then add them together in the end, okay? So here we go. What's f prime? F prime is going to be the derivative of the first, okay? Well, the derivative of the first, do you see you have 2 x expressions here? So what rule are you going to have to use? Product rule. So it's going to be the derivative of the first times the second. Times the second means just carry it down, plus the derivative of the second. So what we're doing is we're saying the derivative of sine u. Okay, that's the second. Well, remember the derivative of sine u is cosine u du dx. My u here is 3x. So all I do is plug into the formula. And you guys need to memorize these formulas, okay? So what I get is cosine 3x, because that's what u is, times the derivative of u, which is 3. That's going to be 3 cosine 3x, okay? So the derivative of the first times the second plus the derivative of the second times the first, okay? And that's my first term, taking the derivative there. And then I put a big fat plus sign, okay? And I start all over. I take the derivative of the right side. What's the derivative of secant u? The derivative of secant u, okay, we've memorized our formula, hopefully, is secant u tangent u du dx. And memorizing your formula helps a lot because students who don't memorize their formulas, because there's 2 u's here, a lot of times they'll call it du dx times du dx, and that's not how we do this. Everywhere there's a u, I'm going to put in 3x. Okay, so this is 3x. So this is 3x. So the derivative of 3x is 3. Okay, so here's my answer right here. I'm going to carry it right up here. So this is going to be 3 times secant 3x times tangent 3x. So let's see if I did this right. Oh, I forgot this scalar here, which is 5. So it's going to be 5 times 3 times secant 3x times tangent 3x. Why didn't I do product rule on the right side? Yeah, there's no x right here, right? There's only one expression with an x. So the 5 is a scalar. So basically it pulls out. I take the derivative of secant x and then it pulls back in. Okay, so I'm almost done. Okay, what do I have here? All I need to do is combine. I can combine this 5 times this 3. And I can also combine this 3 times this 5x. Guys, do not do 2 things. Like 2 things that students do wrong is they multiply the 3x and the 5x. Are you guys okay that 3x and the 5x cannot be multiplied? Okay, why? Because the 3x belongs to the cosine family. Okay, I didn't put a parentheses there. Maybe we should. but you never pull out parts from their family, okay? The other thing is, what some students do is, instead of multiplying the 3 and the 5x, they pull the 5x, I don't know why, but to the very, very front, okay? When you multiply, you can't cross plus signs. Does that make sense? You can't. These plus signs like make this is one family, this is one family, and this is one family, okay? So you wouldn't take this 5x and multiply it by this 5 in the front. Like that would make no sense. They don't belong in the same family, okay? So now if I put this all together, actually let me pull this down, okay? And I'll put this all together right here. The derivative of f will be 5 sine 3x plus 15 cosine 3x, and then plus 15 secant 3x tangent 3x. Okay? Does that make sense to you guys?
Wouldn't it be 15x cosine 3x?
Oh, yes, I forgot an x here. Let me push that in. Yes, thank you guys. Okay, does that make sense to you? All right, let's do another problem. Okay, what if I had this problem? This 2 is actually not part of the problem. Okay, so what if I have to take the derivative of sine pi minus 2x minus 3 raised to 11? Inside of you, okay, I can see it. I mean, you're not showing an expression, but I know it's going on inside of you. You're saying, yay, right? Because you have a minus sign here. So it's actually just like the plus sign. It's actually 2 problems in one. You thought you got to do 1, but yay, oh boy, you get to do 2, okay? So here we go. Let's do the first one. What is the derivative of sine pi? Very good. Okay, the most common mistake is saying that this is cosine x. But do you even see an x here? No x. So this is actually a trick. This is actually a constant. You guys good with that? As a matter of fact, on the unit circle, you know what sine pi is. What's a unit on the unit circle? What is sine pi? Pi's over here. What's the sine value there? 0. So as a matter of fact, this number is really just 0. Not only is it a constant, it's 0. What's the derivative of 0? 0. Okay, so don't let that trick you. Okay, and on this side, make sure you understand. This is really plus a minus, if that makes sense. Okay, because if you see a minus, it's really plus minus, or it's a minus plus, but that's not as, this isn't as helpful. Plus minus, and so what you're doing is you're taking the derivative of this expression here with a minus. So you're going to add what? What are you going to add? 11 times negative 1, which is negative 11, times the quantity 2x minus 3. Bring the power down by 1. Okay, so I didn't say it, but leave the inside alone. Leave it alone. Bring the power down by 1, then multiply by the derivative of the inside. So this answer, when I'm all done, I know you guys probably think it's a little awkward I put a plus here. Sometimes it's helpful, sometimes it's not, and here it wasn't too helpful. But this will be 2 times negative 11, which will be negative 22, times the quantity 2x minus 3 raised to the 10th power. And that's going to be my final answer here. You guys okay with this one? Hopefully I did this one right. Okay. And let's do...
Ms. Chang?
Yes.
Why did you multiply by 2 on the last step there?
Because the chain rule says you take the derivative of the outside. Remember, we're working in layers. Okay. So here's your outside layer. Okay. So it's 11 times 1, which is the power rule. 11. And you take it down by 1 power, 10. Right? And then you leave the inside alone and you multiply by the derivative of 2x minus 3, and that's 2. That's the chain rule.
Thank you.
Okay. All right, let's go to another problem. These right here, are these on your notes? Okay. This is on your test. Okay. This one right here should look familiar. This one was on your last test too. Right, it was on your test, last test. You did conjugate pairs. Do you remember that? But you're wiser now. You could do conjugate pairs. Actually, on this test, if you want to do conjugate pairs again, you can. But I just want to say that a lot of students have problems with conjugate pairs. Okay, this is a minus b. You multiply by a plus b, and the answer is a squared minus b squared. Okay, but instead of conjugate pairs, now you know about the definition of a derivative. And I don't know if you noticed this, but did you notice that this was h to the 0? So you know that the limit as h goes to 0 of f of x plus h minus f of x, this is a minus, f of x all over h. You know that that is the definition of what, guys? The derivative. All right, if that's the definition of the derivative, then there's another way to do this. I mean, you can do conjugate pairs. You should get the same answer. Actually, you should do it at home, okay? So guys, if I could just pull out f and I could just pull out a. Remember we had a whole homework assignment where that's all we did. We just pulled out f and we pulled out a. If I could pull out f and I could pull out a, now I know the secret of getting f prime, right? I know power rule, product rule, chain rule. That's all you need to know. I can get f prime, and that's the answer. Okay, so let's see if we can do this. What's my f in this problem? Oops, I don't want to put it there. What's my f in this problem? Square root of x. Can you pull that out? Because remember, it started out as x, and you plugged in x plus h, okay? And then everywhere there's an x plus h, they plugged in 1 plus h, okay? And you want to go back to the x. So what that means is to go backwards. Okay, we're cycling backwards. Everywhere there's a 1 plus h, you're going to put in x, and that's how you pull the f of x out. Okay, if this is f of x, I actually don't know f of x, so let me just tell you, that's the number one wrong answer. Okay, students tell me that the answer to this is f of x. Is this the definition of a function? No, it's a definition of a derivative. I want the derivative. So if this is f of x, how do you find f prime of x? First you rewrite, okay? You can't do it without rewriting. And then you take the derivative, which is 1/2 x to the negative 1/2, okay? And that's really 1 over 2, and make sure you understand this. You take the x to the 1/2 in the denominator. The x to the 1/2 is really square root of x. Agree with that? Okay. Actually, this is more than just f prime of x. This is really f prime of x when x is what number? 1, right? So as soon as you get here, all you do is everywhere there's an x, you put in 1, okay? And that becomes 1 over 2 times the square root of 1, which is 1. That's 2 times 1, which is 1/2. So this answer is 1/2. And if you did conjugate pairs, you should check it. You should get 1/2 too. So on your test, I don't mind which method you use. Whichever method you think is easier, then you use it, okay? Number 4, though, this number over here, you cannot use conjugate pairs, okay? It is f prime of x, but you cannot use conjugate pairs. What you need to do is look at it, recognize, okay, I know that's a definition of a derivative. Okay, if you know that's a definition of a derivative, then what you'll say is, I need to pull out the f and then take the f prime of x. You guys good with that? And that would be my answer. Okay, so let's pull out my f. Matthew, you okay back there? Okay, let's pull out my f. Guys, when you look at this, can you see what f is? Any idea? 2 sine x, yeah. If you need to be able to pull out your f's, okay? Once you pull out your f, since you know the derivative of sine x, you can actually take the derivative now, okay? And it's not just as easy as that, though. Everywhere there's an x, what do I need to put in? Now be careful. A lot of students will say 0 because they're thinking that this is an alternate definition of a derivative. Guys, when you look at the formal definition of derivative, you find your x up here, or your a, or your c. I think sometimes we call it c too. Okay, what's going to be my plug-in here? It's not 0. What is it? 3. So this answer is 2 cosine 3. And you can't do anything with that answer. Like, that's just your answer. Okay, you can put it in the calculator, but then you'll make it inaccurate. Okay, just leave it as 2 cosine 3. All right, down here, what we're doing is we're testing on the same thing, but instead of the formal definition of a derivative, we are seeing, hey, do you recognize that this is the alternate definition of a derivative? And that's why memorizing your formulas are so important, because if you don't have your formula memorized, you don't even recognize this is an alternate definition of a derivative. Guys, you cannot do conjugate pairs here. Okay, let me just tell you, because if you do conjugate pairs, let me just tell you, the root of 3, the third root of x times the third root of x, okay, the square root of x times the square root of x is x, right? The cube root of x times the cube root of x, that is not equal to x. Does that make sense? Like a minus b times a plus b gives you a squared b. That's going to give you x to the 2/3. That's not helpful. You guys good with that? So the conjugate pairs things really only works if this is just a square root. Okay, if it's a cube root, a fifth root, a fourth root, it doesn't work. So conjugate pairs is not helpful unless you just have a square root. And so what you want to do is not conjugate pairs, but notice, guys, if this is the definition of a derivative, then what's the answer to this? It's the derivative. Does that make sense? You just need to take the derivative, but you can't take the derivative unless you know what f of x is. Okay, looking at this problem, can you pull out your f of x? That's the key. What is your f of x in this problem? Cube root of x. The alternate definition of derivative is even easier than the formal definition of derivative. It's just whatever's in the top left. Does that make sense? Because if you know the formula, you're like, oh, f of x is just whatever's in the top left here. All right. Then what I want to do is take the derivative of this. And some of you guys, I do this, but some of you guys may or may not do this. I check to make sure this is really f of c. So if this is c is an 8, you see this would be an 8, this would be an 8, and this would be an 8. Okay? So if I found f of 8, that means everywhere there's an x, I'm going to plug in 8. Do I really get 2? Because that's what it says f of 8 is. And I do get 2. Does that make sense? So I do a double check. I say, okay, did they really give me the definition of a derivative here? They really did, because this really was 2 when I plugged in 8 right here. Okay? All right, so now I need to find the f prime, so let me rewrite this. F of x is x to the 1/3. Okay, what's f prime of x going to be? 1/3 x to the negative 2/3, right? That's going to be 1/3 times x to the 2/3. Okay, and actually, I could leave it like this, but this is unsimplified, not good for plugging in. Okay, so I'm going to move it down because I'm about to plug in the c, and this will be 1/3. And there's different ways to do this. I'm going to root it. I'm going to third root it first, then square it. You can always square it, then third root it. It gives you the same answer. Okay, guys, the thing is, I don't really want to find f prime of x. What a did I put in, or what c did I put in? What's my c? Look at this. It's 8. Okay, this is my c here and my c here. And just to make sure you understand, if I had written this formula right, it would have been f prime of c, not f prime of x, because the alternate definition of derivative actually plugs in the point. Okay, so this is f prime of 8. But guys, you never plug in the point first, okay? If you plug in the point first, you'll just get a constant. When you take the derivative of a constant, that's always going to be 0. So you never plug in first. You always take the derivative first, then you plug in. And so this would be 1/3 times 2 squared, right? Because I'm going to plug in an 8 right there. That's going to be 2 squared, so I get 1/12. Can someone give me a check on that? 1/12, thank you. Okay. All right, so that's the third warm-up question I had for you. Make sure you're comfortable with that. You'll definitely see it on the test. And I want to address some homework questions right now. So I had a question on number 27. Okay, so guys, let's look at 27 from your homework. And I have h of x is equal to x cotangent of 10 square root of x plus 11. All right, you may or may not see it, but this is a yay problem because you've got a plus sign here. Okay, so all I'm going to do is take the derivative of this, whatever it is, and then add it with the derivative of 11. Guys, what's the derivative of 11? 0. So I'm good with that, right? It's going to be something plus 0. So let me just take the derivative of this. This is going to be product rule, right? Because it's two x expressions multiplied together. So it's the derivative of the first times the second plus the derivative of the second. All right, what's the derivative of cotangent u? Well, the derivative of cotangent u is equal to, it starts with a c, so that's going to be a negative. Change the sign. Negative cosecant u, cotangent u, du dx. You have that memorized, okay? Since you have that memorized, all you do is the u here is 10 square root of x. So you put 10 square root of x everywhere there's a u, okay? Yes. Did I not put negative cosecant? Oh, darn, I wrote the wrong formula. Yes, you're right. Okay, start all over. Apologize for that. Thank you for catching my mistake. Okay. And I just want to point out, I'm allowed to make mistakes, but you guys get docked. So I'm okay up here. Okay. minus cosecant squared u du dx. I need to rememorize my formulas. Thank you. Okay, let's try it again. The u is actually 10 square root of x. The u is actually 10 square root of x. And the derivative of u, okay, so the derivative of 10x to the 1/2. Guys, isn't that 5? Because 10 times 1/2 is 5x to the negative 1/2. Is that right? Okay, so this right here is going to be 5x to the negative 1/2. So I'm just going to plug this right side in right up here. Okay, so this is going to be, think of this. This is negative 5 over square root of x times cosecant squared 10 square root of x. Okay, so all I did was rewrite this and this one up here. So the derivative of the first times the second plus the derivative of the second times the first. Is everybody good? You need to multiply the first back. But be very careful. Don't multiply this x with this because this goes in parentheses. Everybody good with that? So don't connect these two together. Don't pull this 10 square root of x outside of its family. It belongs to the cosecant squared family. Okay? All right. So this is my answer so far, and I think I can simplify a little bit. If I have x divided by square root of x, that's really x over x to the 1/2, right? So when you have the same bases, you subtract exponents. So this is actually equal to x to the 1/2. Okay, x divided by square root of x is actually equal to x to the 1/2. So if I simplify that, so let me leave a space here so I can rewrite the answer. My answer here will be cotangent 10 square root of x minus 5 times the square root of x, because x divided by square root of x is square root of x, times cosecant squared 10 square root of x. And that's my final answer. What is this? Oh, it's a 5. Okay. Did you guys get the same? Did I do it right? Any questions on that? All right. Another question I have is number 29. So let me look at 29. It's find the derivative of y equals 2t 3t squared minus 7 5. Do you guys see that this at first, if you're looking at the outside, it's product rule. Okay, it's the product rule. So when I take the derivative, it'll be the derivative of the first times the second. Okay, so times the second means leave this alone. Plus the derivative of the second. All right, here's the second. Okay, here's the first. So the derivative of the second is going to be a chain rule. You guys see that? That's going to be 5 times, leave the inside alone, bring the power down by 1, and then multiply by the derivative of the inside. Okay? So the derivative of the first times the second plus the derivative of the second times the first. Let me do it in a different color. Okay. Did I make any mistakes so far? Okay, and then from here on, it's just a simplification. You've done most of the hard work here. You just need to see that this is a monomial, this is a monomial, and this is a monomial. So I want those multiplied together. Please don't pull them to the front. This plus sign here divides it, okay? So the answer is going to be 2 3t squared minus 7 to the 5th power plus 30 times 2, that's easier, so it's 60. 60t squared times 3t squared minus 7 raised to the 4th. Okay, if I simplified it right, that's what I have. Okay, any questions? All right, and then another question we had was number 34. So let's look at 34 from your homework, which is due tonight. Suppose the line tangent to the graph of f is x equals 3, x equals 3 is y equals 4x plus 5. Okay, so I don't know the graph of f. So I'm just going to graph f, okay? And if I went to x equals 3, so if x is equal to 3 here, this is my x-axis, this is my y-axis. If I went to x equals 3, then what I know is this slope right here, the equation of the tangent line, is y equals 4x plus 5, okay? And I also know y equals 2x minus 1 is the tangent line of the graph at g, okay? So there's another graph at g, which I don't know what it looks like, okay? but I've also got a graph at G, okay, and I'll just make this like that, not to scale, okay. Say that this is at x equals 3. So they're saying this graph right here, if I did a tangent line, that equation of the tangent line is y equals 2x minus 1. Okay, guys, if I know that this is a tangent line at x equals 3, what do I know about the slope of the tangent line here? What's the slope of this tangent line? What's the slope of this line? 4. Do you agree? And if I know that right here at x equals 3, whatever this point is, this equation is y equals 2x minus 1. That's the equation of the tangent line. What's the slope of the tangent line? 2. Everybody good with that? Oh, but when I say derivative, you say slope of a tangent line. So something else I know is if this is my f graph, which I think it is, then I know that f prime at 3 is 4. You see that? And if this is my G graph, I think it is. Actually, I don't know. Yeah, this is my G graph. Then I know G prime at 3 is 2. Okay, so they've given me some information. And then the first question is find the equation of the tangent line to the curve y equals f of x times g of x. Okay, at x equals 3. Okay, well, what they're trying to fish out of you here is do you know the derivative of f times g? Guys, is the derivative of f times g f prime times g prime? Is that how you find derivative of two things that are multiplied together? No, the derivative of f times g is the derivative of the first times the second plus the derivative of the second times the first. All right, this should be f of x. Okay, and so if I want at x at 3, this would be y prime at 3. So I guess technically this is y prime at x. Okay, everywhere there's an x, I'm going to put in a 3. Okay, and what I'll get here, I know f prime of 3 is 4. I know g of 3. Oh, wait, how do I get g of 3? Oh, just plug it right into this equation because that's the point right there at the tangent line. So this is going to be y of 3, which would be 2, 3 minus 1. So I'm getting 5 plus g prime of 3, which I knew was 2. And f of 3, if I plug it into the equation, I'll get 4 times 3 plus 5. I believe that's 17. Please let me know if I make a mistake. And so that's going to be 20 plus 34, which will give me 54. Okay, I don't know what I found. I found y prime, but let's see what I need. It says find the equation of the tangent line to the curve of y. So whatever this y graph looked like, who knows what it looked like, okay? I'm finding the equation of the tangent line at x equals 3. All right, guys, when they say find the equation of the tangent line, what two things do you need to write down? Point and slope, because you're going to put it into a point slope formula. What's my point? Okay, remember guys, a point is an x comma y, okay, and this over here is the slope of the tangent line. So what's my point? 3, comma, how do I get my y value here? Yeah, you plug in this right here. Do you guys see this? Y is equal to f of 3 times g of 3, okay? And I think I know that. I think I found g of 3 was 5. Does that make sense? And I have found f of 3 was 17. Okay, so y is equal to 17 times 5. 85? No, what's 7 times 5? 35? Is 85? Okay, so that's going to be 85. Okay, how did I do that? Just this formula right here. Y equals f times g at x equals 3. Okay? And then the slope, well, this is the slope of the tangent line, right? So I'm doing everything for y prime. So that was equal to 54. Okay, so then I just put this into the formula. Y minus y is equal to the slope times x minus x. And that's my answer, although my math lab might make you pull the 85 over to the right. Okay, and then number 34, the second part's the exact same thing. You're going to do the quotient rule rather than the product rule. All right. Okay, just for the sake of time, guys, I'm going to move on. And if we have time, we can go back to our homework. These derivatives, you have to have memorized. Okay, I'm just letting you know. There's no way around it. Plus, when we get to integrals, you're gonna have to go backwards on this. So if you don't know this forwards, you're gonna have lots of trouble going backwards on it. Okay, so make sure you've memorized all that. These are formula quizzes I used to give. Okay, I want to go on with our notes. Okay, so formulas you have to memorize besides those trig derivatives is if you want the derivative of f plus g, you need to know that that is basically the derivative of f plus the derivative of g. I mean, it's as simple as that. If I wanted the derivative of 16 g of x, that would be 16 times g prime of x. Okay, you pull out the scalar and you take the derivative of g of x. Okay, it's not that easy when you have two things multiplied together though. Number one wrong answer is h prime, is f prime times g prime. Does that make sense? The derivative of f times g is not f prime times g prime. It is. You guys know it? The derivative of the first times the second plus the derivative of the second times the first. Okay? You have to understand product rule. Okay? You can't just multiply the two derivatives together. Likewise, quotient rule. It is not equal to f prime over g prime. No, you can do that in limits, but you can't do that in derivatives. This is going to be instead the derivative of the first times the second minus the derivative of the second times the first all over the bottom squared. Okay, you guys have that memorized, the quotient rule? And then finally, guys, the chain rule. The chain rule is if you have a composite function, the g is inside the f. That's going to be take the derivative of the outside, leave the inside alone, multiply by the derivative of the inside. And you don't have to have this arrow. Sometimes students ask me, why did you put the arrow? Well, that's just to remind you to take the derivative of the inside, but leave the inside alone, okay? Most common mistake students do here is they think this is f prime times g. Guys, make sure you understand, this is not f prime times g. This is find g and put it into a composite function. Does that make sense? Of f prime. Okay, it is not f prime times g. Okay, this is a composite function going on here. All right, so knowing those, let's go look at some of graphs and tables. Okay, this is actually f times g. One problem they could give you is this: a is equal to f times g. Tell me what a prime of 2 is, and be able to read off graphs and tables. If you want a prime of 2, do you understand? Okay, I mean, students will tell me they understand, but still on the test, they tell me that this is f prime times g prime. Is that how you take the derivative of two things multiplied together? No, it's the derivative of the first times the second plus the derivative of the second times the first. Okay, and if I put this in proper notation, they actually want a prime of 2. So what that is f prime of 2 times g prime of 2 plus g prime of 2. No, wait. Did I do that right? Times g of 2, sorry. Times g of 2 plus g prime of 2 times f of 2. Okay? And you go to the table and read all these, and these are not hard to read off. I've got f prime of 2 is 3. G of 2, I don't know why I keep saying prime. G of 2 is negative 5. G prime of 2 is 1. And f of 2, okay, let me know if I read off anything wrong, is 8. So I'm getting negative 15 plus 8 is negative 7. Can I get a check on that? Anybody else get negative 7? Thank you. All right, so that's how you do product rule. And you guys can see they're testing you on product rule, and then they're testing you on quotient rule. Okay, so let's look at letter B there. Do you see that they want you to do this? They want you to say a prime is equal to f prime over g prime. Do you see that? And it's completely wrong, okay? Because that's not how you do derivatives, okay? Now, if it were limits, you would do that, okay? But this is derivatives. What they're trying to get you to do is tell them that you know the quotient rule, okay? Do you know it? Let's see if we can do it. It's the derivative of the first times the second minus the derivative of the second times the first all over the bottom squared. And they really don't want just a prime here. They want a prime at 6. Okay, so this will be f prime at 6 times g at 6 minus g prime of 6 times f at 6 all over g of 6 quantity squared. All right, so you'll go to the table, pull all of these values. So if I wanted f prime of 6, I'm getting 27, g of 6, I'm getting -1, g prime of 6, I'm getting 16, f of 6, I'm getting 26. This is looking pretty bad. G of 6, getting -1. So if I simplify this, I'll get -27 minus 16 times 26 all over -1 quantity squared, guys. It's just 1 in the denominator. Okay, and then you guys can figure this out. Did you guys at least get 16 times 26? Just checking my numbers with you. Okay, good. So you guys figure that out, and I'll stop there for you. I want to look at C. C is a little tougher. It is the chain rule, all right? And so you want to find a prime of x, and the way to find that is this, okay? You're going to work in layers, okay? The outside layer first, okay? We're looking at the outside layer. Do you see the outside layer is a power rule? Okay, so it's going to be 5 times 1, which is 5, okay? This is the inside. Leave the inside alone, bring the power down by 1. Leave the inside alone, bring the power down by 1. Okay, so here's the inside, f of x squared, that's the inside. Bring the power down by 1, but don't forget to multiply by what? The derivative of the inside. Now this is a little tricky, okay? The derivative of the inside, I'm not gonna multiply it yet, I'm just gonna put it here. What is the derivative, what if I said, what's the derivative of f? Could you give me that? Isn't it f prime? Okay, okay, but a little bit trickier. What is the derivative of x squared? That's going to be chain rule. It's going to be the derivative of the outside. Leave the inside alone, then guess what you have to multiply by? The derivative of the inside. When I asked you what the derivative of f was, it was a little bit of a trick question because it's the derivative of the outside. Leave the inside alone, but then take the derivative of x. What's the derivative of x? 1. And so we never talked about multiplying by 1. Does that make sense? But you really did. This was actually f prime of x times 1, which just turns out to be f prime of x. But this is f prime of x squared times 2x. Do you see that? So this becomes 2x times f prime of x squared. Okay? And so what I'm going to do is I'm going to simplify this. The 5 and the 2x can multiply together. So that's 10x times f of x squared raised to the 4th power times f prime of x squared. Were you able to move it down that far? Now I don't want a prime of x, really. What do I want? A prime of 2. So everywhere there's an x now, plug in 2. Okay? So that's 10 times 2, which is 20. F prime, f, plug in your 2, which is f of 4, okay, raised to the 4th power, times f prime. If I plugged in 2 here, I get f prime of 4. Okay, so a little bit trickier of a problem. The f of 4, if I go look at my table, that's 14. The f prime of 4, if I look at my table, that's 9. So what I get is 20 times 14 to the 4th power. Make sure PEMDAS, do the exponents before you multiply by 20, times 9, which is 180 times 14 to the 4. I don't remember these big numbers like this in first period. Did you guys get the same? Okay, good. And then multiply this together, and that'll be your answer. Okay? Make sure you multiply, do the exponents first. All right, on the top of your second page, this problem is even easier. I don't know if you see it, but it's just saying, you know what? I'm just gonna, you don't even have to look at a table. Does that make sense? Or a graph to get your f and f primes and g primes. I'm just gonna give it to you. So sometimes they just give it to you, okay? Actually, you probably always think that I'm giving it to you, but since it's supposed to be easy, all right? So if you wanted the derivative of h, okay, because that's what they're asking for, guys, always find the derivative of x before you plug in your 3. If you plug in your 3 first, you're just going to get a number. It's not going to get you anywhere. Then you take the derivative, you're just going to get 0. Okay? So f prime of x is the derivative of the outside. Leave the inside alone. Multiply by the derivative of the inside. That is the chain rule. Okay? And if I want h prime of 3, that just means go through. Everywhere there's an x, plug in a 3. Okay? And again, the most common mistake students do here is they get the chain rule right, which is really what they're trying to trick you on. But right here, guys, this is not f prime times g. Guys, it is not. It is a composite function. Okay? So first, you plug in your g of 3, which they tell you is 2. Okay? So what they're saying is find f prime of 2 and multiply that by g prime of 3, which you know is negative 5. And f prime of 2 you know is 1, because you can read it off the information they gave you. And so your answer is negative 5. Okay? Did I do it right? Okay, good. All right, let's go look at some graphs. Graphs are way more fun than tables because you actually have to pull off numbers, usually off slopes. Okay, so let's look at actually, I'm going to spare you guys with the product rule. I'm going to assume that you guys know how to do it, so you guys can write down this answer. That answer over there is negative 1.5. You can do it at home if you'd like to check it. But I'm going to do the left side here with you. Okay, if they want you to find h prime, and they give you h is equal to f prime plus g prime, then h prime of x is actually equal to f prime of x plus g prime of x. Are you good with that? That's the sum and addition rule, right, in derivatives. All right, same thing with limits, you would do the same. So if you want h prime of 4, then that's really just f prime of 4 plus g prime of 4. Okay, now here's the tricky part. How do I find f prime of 4? Go up to your graph, to your f graph. Okay, find your number 4 and find that point on the curve. Okay, what's f prime at 4? It's the derivative of f at 4, which is the slope of the tangent line at 4. Is everybody good with that? So what I do is I get closer and closer and closer to this dot until it looks like a line. Okay, and I extend that line. That is going to be my tangent line. Okay. And I want the slope of that line. Does that make sense? And how do I find the slope of that line? Well, that slope of that line is going to end up being this line. Does that make sense? Because it's on a line. So you get the slope of this line. So what you do is you find 2 points. You do y minus y over x minus x. So I have here 6 over 3. So that's going to be negative 2. Does everybody see how you got f prime? It's the slope of f at the point 4. But you have to do a slope of a tangent line. All right, let's do g prime at 4. Same thing, go to your g graph, go find 4. So 1, 2, 3, 4, right there. Okay, get the slope at that point right there, the slope of that graph at that point. Draw a tangent line, and I'm getting 1/2 right there. Okay, so negative 2 plus 1/2 is negative 1.5 or negative 1.5. All right. You guys good with getting the slope of this thing? Okay, so they can throw in some harder things. I'm going to leave the product rule and the quotient rule there. I'm assuming that you guys can plug those in. I'm going to go down more to the chain rule problems, just because you're not as familiar with those, but you need to be able to do the product and the quotient rule too. Actually, let me go back. The answer to the quotient rule problem, you guys can write it down now. You can check it on your own, is 7/4. Okay, it's 7/4. So y'all can check that on your own. Okay, let's go down to D and E, which are going to be a little tougher to do. Well, I don't know if they're tougher. It's chain rule. It's chain rule, which you guys are probably need a little bit more practice on. Okay, if I wanted Q prime, okay, and I know Q is G of f of x. Do you see that is the derivative of the outside? Leave the inside alone times the derivative of the inside. You see that? So what I want though is not Q prime of x. I want Q prime of 4, right? So that's going to be everywhere there's an x, I'm going to plug in a 4. Now be careful. I mean, what students do wrong is they do G prime times F here. This is not G prime times F. This is G prime times, plug in the F of 4, or not times, G prime at F of 4 times F prime at 4, okay? How do I find F at 4? F at 4. Go to your F graph, look at 4, and you read your F value. So it's 1, 2, 3, 4, 5. I'm saying F of 4 is 5. So what I'm really doing is I'm getting G prime at 5 times F prime at 4. It's not G prime times 5. You guys good with that? It's not a multiplication here. This is plug in the 5 into your G prime. So to get G prime, go to your G graph. Here's my 5. And how do I get G prime? It's the slope. You guys good? So I get the slope right here at 5 of your G graph. And I'm getting 2 over 1, 2, 3, 4. I'm getting 2 over 4, which is positive 1/2. Okay? So this is going to be 1/2 times F prime at 4. So here's 4 of your F graph. It's F prime, so you want the slope. The slope at this point, and I think we found it before, was it 2 or negative 2? Negative 2? Okay, so your answer here is going to be 1/2 times negative 2, which is negative 1. Can you guys do that on your own? Okay, well, let's see. Go ahead, guys. See if you can take the derivative of E. Okay, the derivative of R over here. Letter E says take the derivative of R. See if you can do that. Take the derivative of the outside. Leave the inside alone. Then multiply by the derivative of the inside. So there's my outside right there. There's my outside. We're going to work this in layers, like an onion, okay? So it's 3 times 1. Leave the inside alone. Take the power down by 1. Multiply by the derivative of the inside. Okay? So what I get is R prime of X, but I really don't want R prime of X. I want R prime of 4. So this is going to be 3 times F, plug in your 4, times F prime, plug in your 4. Okay, what do we get for F of 4? 5. So this is going to be 5 squared times 3. Remember, square before you multiply by 3. What do we get for the derivative at 4, F prime at 4? Is that negative 2? I'm just remembering. If I have it wrong, let me know. Okay, so that's going to be 3 times 25, which is 75, times negative 2. And can I get a check? I'm getting negative 150. Okay. All right. How are you guys feeling about chain rule, product rule, power rule, all of that? Okay. So let me just let you know your homework, because your homework is on my math lab. It has some problems like this. I think I found a product rule problem and a chain rule problem, but it doesn't have a product rule problem and a quotient rule, but it doesn't have the chain rule. And on the AP exam, they're big on all of these. Okay. And chain rule, they are big on. So I just want to let you know, we're doing it here, but you're not going to see on your homework that the last two problems, the chain rule. But you need to be able to do it, okay? The chain rule is super important with these F's, taking the derivatives of the F's in here, all right? Okay, we have maybe, I don't know, 3 minutes in here, 4 minutes. Is there any other homework questions that you guys would like me to do really fast? You're doing your homework and you had any trouble on homework? There are some tough ones in there, so let me know. No, it's the same homework you had Friday. Yeah, you just need to finish it up. If you didn't know, then you probably didn't finish. Then you probably finished it up already. But guys, sorry. When I came home on Friday night, I realized that your homework was for 2 days, and I didn't tell you that. So I sent an update on Schoology. So if you look at Schoology, you got the update. If you didn't, then you didn't get it. Sorry. Is there any homework question that you did that you had trouble with? Yeah, Ralph. No, you don't. But pretty soon here, after tomorrow, I'll post the solutions or post some set of solutions, and I want you guys to start checking. Because if you're getting it wrong here, you don't even know. Does that make sense? The students on my math lab know. So, and if you have trouble, go do it in my math lab, and I'll give you the answer. Okay. You guys are good on homework? Okay, there are some tricky questions, so I'm gonna leave you guys there. You guys can just work on homework. Yeah, Mateo? 16, is that what you said? Okay, guys, look at 16, guys, on your homework. Yeah, there's a whole bunch of these, but what they want you to do is see a pattern. So if you take the derivative of this, you see it's chain rule, so it's going to be 2 times, leave the inside alone, times the derivative inside. But then if you do sine of x raised to the 3rd power, what you'll get is 3 times sine of x, bring the power down, cosine of x, right? And then you do the power of 4, what you get is 4 times sine of x, bring the power down, and you get cosine x. Well, they want you to do a generic one for n. So this would be, see if this makes sense. This is n. Do you see, you just copy this number here, right? So it's going to be n times sine of x, and then this power goes down by 1, right? So that'd be n minus 1 times cosine of x, and that should be your answer. Okay? You guys have any other questions on homework? And I don't really need you to memorize this pattern, but I wanted you guys to see you cannot leave things like this in order to take the derivative. You have to rewrite it. Okay, if you don't rewrite it, chances are, actually I would say 100% chance, the students who don't rewrite it get it wrong. Okay, you need to rewrite it with that square on the outside or the cube on the outside to do the chain rule on these problems. 25. We're going to start with 25, guys. Look to see what homework questions you need help on, and let me see if I can help you here. All right, guys, on 25, we want to take the second derivative. Okay, oops, I got this confused. The second derivative of 3x cosine x squared. Okay, y equals. And I had another question in first period, just to clarify, because these questions came from different books. On number 28, that 11 pi t, it's in parentheses. Okay, I know sometimes they put it in parentheses and sometimes they don't. If you notice like an asterisk by your number, actually it came from a different book. So we're mixing books in here, and that's why some of the notation is different depending on which book we use. What did you say, Alex? Yeah, sorry about that. Yeah, it's not product rule. It's actually a chain rule. Okay, with this sequence. So I apologize for not number 28, but make sure you do parentheses there. All right, guys, this is going to be product rule first. It's going to be the first derivative. So it's going to be the derivative of the first times the second plus the derivative of the second, which would be negative sine u. I'll just put here negative sine u times u du dx, right? Isn't that the derivative? The derivative of cosine u is negative sine u du dx, and that's what I have right here. Okay, the derivative of the first times the second plus the derivative of the second times the first. Okay, if I simplify this, I'll have 3 cosine of x squared and negative times 3x times 2x. So I have negative 6x squared sine x squared. Okay, so that's going to be my y prime. They want you to do y double prime. Okay, so this is going to be 2 problems in one, and I just put a plus sign in the middle. Okay, this is a minus, so I'll put a minus sign in the middle. This would be the derivative of just this side here. Remember, the derivative of cosine u is negative sine u du dx. Okay, so the derivative here will be 3 negative 3 sine x squared times 2x. Do you agree with that? All right, now be very careful here. Anytime you're doing derivatives, when you see a minus, it's really plus minus. Okay, so what I'm going to do is I'm going to put a plus sign. I'm going to take that negative 6x squared, and that's going to be my first. And this will be my second. And I can't emphasize to you guys how important this is. I'm glad you guys pointed out this question, because when we do implicit differentiation on Wednesday, this is where students have trouble, okay? But if you do this little trick, if you see a minus and you need to take the derivative, do a plus minus, okay? Take the negative and push it in with the 6x squared, and you'll get the right answer. Okay, we're going to add what? We're going to add, this is going to be product rule, the derivative of the first times the second plus the derivative of the second, or the derivative of sine u is cosine u times du dx, okay, times the first. But the first was negative 6x squared. Okay, so let's see if I did this right. The derivative of the first times the second plus the derivative of the second times the first, okay? All right, and so then I'm just going to combine stuff here. Negative 3 times 2x is going to be negative sine 6x, sine x squared, okay? This will be, this one I can't simplify. The middle term's just negative, but I do have a plus minus, so I'm going to simplify that to minus 12x sine x squared, okay? Over here, not much to simplify, but I'm going to move the negative 6x squared to the front. Guys, I cannot move it to the very, very front, okay? Once again, these plus signs separate all the terms. So when you move something to the front, you can only move it to the front of that term, okay? So this becomes negative 6x squared times, wait. Actually, I can multiply by the 2x, sorry. The 2x, yeah, the 2x is also a monomial. This is being negative 12x cubed cosine x squared. Okay, then I kind of look for common things to combine if I can. And if there are variables, I can combine them as long as they're the exact same variable. Does that make sense? It has to be exactly the same. And I think these are exactly the same, unless my eyes are fooling me. Okay, these are exactly the same. So this becomes negative 18x sine x squared. Okay, and then I'm just going to carry over this negative 12x cubed cosine x squared. Okay. What other questions do you guys have? 34. Okay. So 34, I think the hard part is just understanding the question. So let's look at 34. 34 says I have this f function, okay? And this f function, I don't know what it looks like. Okay, so I'm just going to graph the f function. I have no idea what it looks like, okay? I know that if I go to 4, that tangent line right there, that tangent line, the equation of the tangent line is y equals 4x plus 5. That's the equation of the tangent line, okay? Now, I need to tell you something, though. Oh, sorry. Yes, you're right. Thank you. Okay, and this is f. So let me go ahead and label this blue graph f. This is my f graph. Okay. Now let me ask you something. If this is the equation of the tangent line at 3, what's the slope of the tangent line at 3? Not quite. That's the y value. What's the slope? Like if this is an equation, what's the slope of this equation? 4. Does everybody get that? So do you agree that the slope of the tangent line at 3 is actually equal to 4, right? Because the slope of the tangent line is a derivative. And if this is a tangent line, if that's a tangent line, the slope of that is the derivative, right? And the other thing that I need to pull out of this is f of 3. If this is 3 here, what's f of 3? Well, f of 3, I actually don't know what f is, so I can't plug in an f. But I do know this point here is both on f and on the tangent line. Does that make sense? That tangent line and this f intersect at this point. So this tangent line here, if I plugged in the 3, it is what this point is right here. Okay, so that's going to be 4 times 3 plus 5, which is 17. Okay, so those two pieces of information you need to know. And you need to do the same for g. Okay, so if I draw g, and g says at x equals, that's also x equals 3. Okay, so at x equals 3, okay, right here, x equals 3. Okay, if I drew a tangent line right there, if I drew a tangent line, okay, that equation of the tangent line is y equals 2x minus 1. Okay, so this is my g. This is my g graph. Okay, so question for you. What would be g prime at 3? What is the slope of the tangent line to? Okay, what would be g3? Okay, yeah, that would just be plugging in. Okay, once again, I don't know g, but for sure, this dot here would be satisfied by this tangent line at 3. So this would be 2 times 3 minus 1, which is 5. All right, that gives me a lot to go on because the next question says, what is the equation Okay, so this is part A. What is the equation of the tangent line of y at x equals 3? Now remember, when they ask you for an equation of a tangent line, you need to put it in a point slope form. So what two things do I need? Write it down. I need a point and I need a what? I need a slope. Okay? Well, what's the point? You agree I got 3 right here, right? And this is xy, so I'll just put y there. I don't know what y is. But they do tell me that y is equal to f of x, g of x. F of x, g of x, right? And I do know that x here is equal to 3, right? So that means my y of 3 is equal to f of 3 times g of 3. Well, do I know what f of 3 is? Isn't it 17? Do I know what g of 3 is? Isn't it 5? So if I multiply those together, my y here is actually 3, oh, thank you, 85. Okay, do you see, I just need to get numbers here and they kind of manipulate, see, okay, I need an x, I need a y. They gave me the y as f times g. I know the x is 3. Okay, so what's the y? All right, the slope. Remember, this is the slope of the tangent line, right? So it's y prime, right? It's a derivative. When I say derivative, you say slope of a tangent line. So this is just the slope of a tangent line. It's a derivative. The derivative at 385. You hear that? Okay, but what's y prime? Now, what are they testing on here? They're saying, if you know that y is equal to f times g, what's y prime? It's a little bit of a trick. Isn't y prime equal to the product rule, right? It's the derivative of this, which is the product rule. So it's the derivative of the first times the second plus the derivative of the second times the first, okay? So, but you actually have to plug in 3 for all your x's and 85 for all your y's. There's not any y's here. So this would just be f prime at 3 times g at 3 plus g prime at 3 times f at 3, I think, okay? And so then all these numbers we know. We know f prime of 3 is 4, we figured that out. We know g of 3 is 5, we figured that out, 5. Plus g prime of 3 is 2, times f of 3 is 17. So that's going to be 20 plus 34, I think. So that's 54. Let me know if you see something else. Okay, and that was my goal. Get a number for the slope and get a number for the point, and now I'm home free. The answer is y minus y is equal to the slope times x minus x. Okay, and that is a great answer. If you're on my math lab, they might want you to add 85 to both sides. Okay, but this is a great answer. Okay, and I'm going to let you guys do the part B by yourself. It's the exact same thing, but your y is equal to f divided by g, and your y prime now is going to be the quotient rule. You guys see that? Okay. All right, let's move